Hi kids, previously we studied about acids and bases. Now it's time to understand metals and nonmetals. Here are the objectives of this video. What is meant by physical properties of matter? Understanding physical properties of metals. Understanding physical properties of nonmetals. Differences between metals and nonmetals. Where are metals and nonmetals placed in a periodic table? How do metals and nonmetals interact with each other? What are the properties of ionic compounds? A property like color, hardness, boiling point, odor, etc. of matter that tells us about the appearance of a substance is termed as physical property of that substance. Physical properties can be observed or measured without changing the composition of matter and are used to describe matter. For example, in here you can see the physical properties of a ball. It is spherical, made of rubber, is solid, is bouncy, and red in color. Some of the metals we daily use are copper, iron, gold, silver, and aluminium. Let us now know the physical properties of metals, the characteristics that make us call a substance a metal by its appearance. Generally, metals are solid in nature, except for few like mercury and gallium, which are liquid at room temperature. Metals are shiny or have luster. Metals are generally hard. The hardness varies from metal to metal, except for some alkali metals like sodium and potassium, which are soft. Metals are sonorous. They have a distinct metallic sound to it, just like this church bell. Metals are malleable, that is, it can be drawn into thin sheets. Gold and silver are the most malleable metals. Metals are ductile, that means to say it can be drawn into thin wires. Gold is the most ductile metal. It is because of their malleability and ductility that metals can be given different shapes based on our needs. Metals are good conductor of heat. In here you can see how the heat travels from one point of the metal to another. The best conductors of heat are silver and copper. Observe this experiment. You will be able to see that only when the circuit is connected with copper and steel will the bulb light up, telling you that metals are good conductors of electricity. Now it's time to look at the physical properties of nonmetals. Here are some examples for nonmetals. They are sulfur, carbon, bromine, and oxygen. Look at their appearance. They do not have luster, right? Hence they are called as dull. They generally occur as solids or gases, except bromine, which is a liquid. They are not lustrous, except iodine. They are non-sonorous. They are brittle in nature, that is, they can be easily broken into pieces, hence are not moldable like metals. They are bad conductors of heat and electricity except for graphite and diamond, which are allotropes of carbon. And they are not hard except diamond. Here are the allotropic forms of carbon, the ones that showed exceptions, diamond and graphite. Allotropic forms are structurally different forms of the same element, and graphite and diamond are allotropes of carbon. Though both contain carbon atoms, they possess unique properties because of the variation in the structure. Now it's time to look at the difference between metals and nonmetals. Basically, we'll be looking at the differences in their physical properties. Let's start with appearance. Metals are lustrous, nonmetals are dull. The physical state at room temperature. Metals are generally solids. Nonmetals are generally solids or gases. Bromine is a liquid though. The sonority. Metals are sonorous. Nonmetals are not. Malleability. Metals are malleable. Nonmetals are not. Ductility. Metals are ductile, whereas nonmetals are not. Brittle. Metals are not brittle, nonmetals are brittle. Good conductor of heat. Metals are good conductors of heat. Non-metals are not. Good conductors of electricity. Metals are, whereas non-metals are not. Melting point. Metals have a high melting point. Non-metals have a low melting point. Density. Metals have a high density, whereas non-metals have a low density. In here, you can see where the metals and non-metals are found in the periodic table. On the left-hand side of the periodic table, you can see metals like sodium, calcium, iron, and aluminium. Hydrogen, being a non-metal, is the only exception and is found on the left. On the right-hand side, you can see non-metals like carbon, chlorine, phosphorus, krypton, etc. At the junction of these metals and non-metals, you find another set of elements. These are generally termed as metalloids, and they have properties similar to both metals and non-metals. Now it's time to look at how metals and non-metals interact with each other. Let us look at a metal atom, say a sodium atom. Sodium atom has 11 protons and 11 electrons. The way in which the electrons are arranged in an atom is termed as electronic configuration. Here it is 281. An atom is said to be stable if it has 8 electrons in its outermost shell, and it is called as octet configuration. The configuration is termed as octet configuration. How many electrons does a sodium atom have in its outermost shell? 1, right? You can see it here too. So, if it loses this 1 electron, it will attain octet configuration or stability, because the previous shell already has only 8 electrons in it. So the sodium atom has to lose, and it will easily lose this electron to attain stability. When it loses an electron, the balance between the electrons and protons is hampered. That is, initially the number of protons and electrons are 11. When you add this plus 11 charge with minus 11 charge, you're going to get 0. That is the charge on a neutral atom. But when it loses an electron, the total will become like this. It is plus 11 and minus 10, right? Then you get plus 1. That means to say the charge on this new sodium is going to be plus 1, and it will become a positive ion. So it will be represented as Na plus. Positive ions are termed as cations. Now let us look at an atom of a non-metal. Let's say chlorine atom. Let us apply what we learned till now to chlorine atom too. Pay attention to the outermost shell. How many electrons do you see in the outermost shell? 7, right? So to attain stability, that is to attain 8 electrons in the outermost shell, it needs 1 more electron. This is more easier, right, to take in 1 more electron rather than give away all these electrons. So it uses the easier method and gains 1 electron and reaches octet configuration. When chlorine atom gains an electron, the balance between the electrical charges changes. Before, the overall charge on a chlorine atom was 0, because plus 17 and minus 17 is going to give you 0. That is 17 protons and 17 electrons. After it has gained an electron, the number of protons remains the same, but the number of electrons has become 18, so therefore the negative charge now is 18, which is represented by minus 18 here. Now when you add it up, you're going to get minus 1, and this will be the charge on the chlorine now. So chlorine gains 1 electron and becomes Cl minus, or a negative ion, and negative ions are called as anions. Generally, metals have 3 or less than 3 electrons in its outermost shell. So the best thing for them to do is to give away electrons and become positive ions. These positive ions are also called as cations. Whereas in nonmetals, they generally have 4 or more than 4 electrons in their outermost shell. So therefore, it is easier for them to gain electrons and become negative ions. Negative ions are also called as anions. So you do see a pattern out here, right? What will happen when plus and minus come together? They attract each other. Remember this and we'll move forward with it. Look what is happening. Sodium is losing its outermost electron to chlorine. So sodium becomes a cation and chlorine becomes an anion. They attract each other with a strong electrostatic force and form an ionic bond, producing a stable ionic compound called as sodium chloride. Nonmetals and metals generally interact in a similar manner and form ionic compounds. Let's look at another example. Magnesium has an atomic number of 12 and hence an electronic configuration of 2, 8 and 2, and thus has 2 electrons in its outermost shell. A chlorine atom has 7 electrons in its outermost shell and needs 1 more electron to attain octet configuration. When Mg reacts with chlorine, 1 Mg is going to give 2 electrons and hence become 2 plus. Whereas 2 chlorine atoms take up 1 electron each from this magnesium and therefore you get 2 Cl minus. That means to say 2 different chlorine with 1 extra electron. Hence, when they both attract each other, you are going to get the formula as MgCl2. That means to say 1 magnesium which has 2 positive charges has interacted with 2 different chlorine atoms with 1 negative charge and hence the formula becomes MgCl2. Now let us look at the properties of ionic compounds. The compounds that are formed by the interaction between metals and nonmetals. Because of the strong electrostatic forces that exist in ionic compounds, they have the following properties. Ionic compounds are usually hard and brittle solids. They have high melting and boiling point. This is because a considerable amount of energy is required to break the strong interionic attraction. Ionic compounds are generally soluble in water, where they break up into ions, and insoluble in solvents such as kerosene and petrol, etc. Ionic compounds conduct electricity in the molten state when the ions can move freely and conduct electricity. Let's recap what we have learned. Metals are lustrous, sonorous, ductile, malleable, have high melting points, hence solids at room temperature. Have high density, are good conductors of heat and electricity, example iron, aluminium, gold, silver, etc. Nonmetals are dull, brittle, non-sonorous, are bad conductors of heat and electricity, example sulfur, carbon, phosphorus, etc. Nonmetals are mainly found on the right-hand side of a periodic table and metals are on the left. Metals generally have the tendency to lose electrons, hence form positive ions called cations. Nonmetals generally gain electrons and form negative ions called anions. Metals and nonmetals interact with each other to form ionic compounds. For example, sodium chloride, sodium fluoride, magnesium oxide, etc. Thank you kids. Hope you understood more about metals and nonmetals through this video. If you have any doubts, please feel free to contact us.